Okay, so we're going to do three different things today. First thing is I'm going to talk about the use of the of two operators that we haven't studied before. We haven't needed them before. You're probably going to need it for the current assignment. You probably get by without it, but you'll probably need it. It's the first thing we're going to do. Second thing we're going to do is we're going to do a little TDD, a little test-driven development. I'm only going to give you guys a couple of the test cases that I have for the current assignment, just to make sure that the format that you have, the syntax, you're not printing out my Figlet, thing, is correct. I'm only going to give you a couple. There's still going to be lots of test cases. I'm only going to give you a couple of them, and I want you all to collectively crowdsource test cases for the current homework assignment, and I want you to test it yourself. And we'll go into that when we get into part 2. And then part 3, we're going to get to bitwise operators. If there's time. If not, we'll continue it on Friday. So let's get going. First thing we're going to talk about is the use of the OpenClose parentheses operator and the OpenClose square bracket operator. So let's say I'm making a point class, which I have for the current assignment, and I've got double x and double y. All right. And I've got a constructor, double new x, double new y, x is initialized with new x, and y is initialized with new y, like that. Okay. So, it'd be kind of cool, right? Point P, which we're going to initialize with, 3.1 and negative 1.1. It'd be kind of cool if we could treat this like an array, right? Like P square bracket 0. P square bracket 1. Know what I'm saying? That'd be kind of cool, right? So, for a point, it doesn't really matter, but for bigger things, like a vector, let's say, the vector class has the square bracket operator overloaded for it. And so it allows you to treat something like it's an array, like it's a C-style array. Vectors are just classes. There's not anything special about them. They're not part of the language. Arrays are part of the language. Vectors are part of the standard library, which is not the same thing, right? The standard library uses the language, but you don't have to use the standard library if you don't want to. Okay, so we can do this by using operator square bracket. So the square bracket operator can be overloaded, and it's going to take one parameter of type size t index, and it's going to return a double, I guess. Or you can say auto. We're doing C++20, and this is going to be a constant method. And actually, nah. Let's have it do something a little more interesting here. Let's not make it const. Okay. Because sometimes we want to write to it using square brackets, right? So that, and then we will return. Okay, so if index equals 0, return x. Else if index is 1, return y. And then whenever you're returning a reference to something, you can't return a null reference, right? So that's one of the reasons why exception handling exists, is because there's literally nothing we can return in this case if they type in a bad index. So we will throw runtime error that is found in except. So we'll throw a runtime error saying out of bounds. And there we go. Okay, so compile, run, and there you go. And because I'm returning a reference, if I just returned a regular double, this code would work. Here. If I just returned a double, this code would work. See, no problem. But if I return a reference is like a pointer that doesn't act like a pointer, right? It's a pointer, but it acts like a regular variable. And so this would allow me to do this, right? So it's returning a pointer, to the element, but it acts like a regular variable, so I can just set that variable to 7.7 without having to do any pointer stuff, right? See how cool that is? And now it's 7.7, right? Oh my gosh. What the hell? Getting beeped.
Oh, it's you.
Yep. Okay. What do you guys think? You like it? Kind of cool? Yeah. All right. So, yeah, this is a very common thing. Anytime you have like a big aggregate type, a lot of times people will overload the square bracket operator on it. How does that help us on shapes? This one doesn't. It's just kind of a random aside. It's just an operator that I haven't taught you that actually comes up a lot, so I was like, I'll just go over that. The thing that is going to matter is the OpenClose parentheses operator, which is a little harder to understand. Okay, so double operator, OpenClose parentheses, taking in no parameters, constant method, and let's have this thing like return the distance the point is from the origin. Okay. Return hypot xy. Okay. Is that CMath, I think? There we go. All right. So, what does it mean by the OpenClose? This is the function operator, right? So if we do this, we're treating a variable as if it is a function. If you have the function operator overloaded on it, you can treat a variable as a function. You can treat functions as variables too. There is a variable type called function in modern C++ that will allow you to treat variables as functions, and if you do this, you can treat a variable, or an object more specifically, a variable of class type, as a function. Yeah, no ampersand, no pointer stuff. It's just calling p as if it was a function. And so let's see out the result of this. And this is going to tell us how far the point is from the origin. Okay, so 3, 4, 5 triangle. We get 5. There we go. Okay. So how is this going to help you on the shapes assignment? Well, my implementation of it uses a hash table. And here's the thing. Can we put this point class into a hash table? If I use stud unordered set. You mad at me? You mad at me? No? Okay. It's got 0 chill. All right. So can I make a unordered set of points? Does that work? Hash map. It can't. All right, and that's a problem. So, why can't I? Well, it doesn't know how to hash a point, right? It knows how to hash integers and doubles and strings and everything in the standard library and the built-in functions and built-in types and all that stuff. It doesn't know how to hash a point. Which bucket does this point go into? It's the same reason why we can't see out it until we write a operator double left arrow, right? You guys see what the problem is? Does this go into bucket 5? You know, like when we say a set dot insert p, you know, which bucket should p go into? All right. C++ doesn't know how to hash it. Now, Java has an advantage here. So Java, every object in Java has a hash method on it, a hash member function on it, that will tell a hash table which bucket it should go into. And that's nice. And so all you would have to do, if this was Java, is just like make a thing called hash and return 1,000 times x plus y. Just some repeatable thing that will give different buckets for different points. It doesn't really matter. I mean, it does matter, but this is actually kind of terrible, but it would work. So this doesn't work, though, in C++. Okay. So what you have to do is something that is pretty gnarly. Okay. What part do we need the hash table for? You need to give C++ a hash function that will hash a point, and there's a lot of ways of doing this, but if you want it actually inside of your class, it's kind of gnarly. I'm just going to copy and paste this because. There. So I've added a class within a class. I have a hash class with struct technically, but a class within my point class. And it's got the operator parentheses overloaded on it. And so this hash class acts like a function. And so what you do is you pass in point and point colon hash. And so this is the type that we're going to do our hash map on. And this is the function that hashes a point. It takes a point and it returns a bucket. Yeah. And so this thing here is kind of mind-blowing, right? Because like if you look at this, it's returning std colon hash, open close parentheses, and then another open close parentheses. Like what? But it's the operator open close parentheses. It's actually a class that acts as a function, and it takes one parameter to its function, and then it uses that stupid hash method that I just showed you to return a bucket that it will go into. And now it works. So that's the part that you need if you want to make your point class hashable. Now you could just write a global function or whatever to do the same thing, but if you want it to be like a member of the class, which makes a lot of sense, right? It makes sense that a class knows how to hash itself, right? It's kind of where I'd expect it to be. Then there you go. That's how you do it. So would you need to use a hash or would a vector suffice? If you use a vector, then your running time is going to be order n squared, because basically you have to check for duplicates in the points. If you ever get a duplicate point, then it's probably going to be an other, right? So if you're doing a rectangle and it goes 1, 2, 3, and then it goes back up to the same point for 4, that's not a rectangle, that's another. So you have to check for duplicate points. And if you did it with a vector, you could say for every point, check every other point to see if it's the same. Order n squared. Not great. Okay. If you use a hash table, then every time you see a point, you put it into the hash table, the unordered set. And then every time you find a new point, you can check to see if that point's already in there. If it is, then it's a duplicate. Okay. And the first and the last points have to be the same. All the other ones have to be different for the triangle and the rectangle class. Okay. Do you need to solve for slope, length, and area by Friday? No, you do not. What you need to do by Friday is just simply have the member variables there. So if the triangle class requires you to compute the area, you don't have to compute the area. That's for part 2. That's for the person you're passing your code to. All you need to do is have the member variable for area in your class.
Is it a different Kearney?
That is Dennis Kearney. Yeah, he...
Different or relative?
That is not a relative of ours, but yeah, he was a famous anti-Chinese speaker, and then I married a Chinese woman, so I don't know. Okay, so yeah, this is 100 years ago. It's not a relative of mine. Same last name. Is there an input tester for this part due on Friday? No, that's what I just said. You guys are making the input testers. In fact, right now, it is now going to be a lab time. You're going to have, I don't know, 20, 30 minutes, and you're going to make input files. So you're going to crowdsource essentially the input files for this homework. I have input files. I'm only going to give you a couple of them, okay? And just to make sure that you're spelling things properly and stuff like that, right? I should probably take out the figlet as well. Let's get that taken out of there so it doesn't do huge anymore. Okay. And then if we do input file 3. So input file 3 has 5 points in it. 0, 0, 10, 0, 10, 10, 0, 10, 0, 0. 5 points, closed loop. All the angles are 90 degrees. That is a rectangle. Okay. So that's, if we look at input file 3, that's the input, and the output is rectangle, along with all the points. Okay. All the rectangles be axis aligned? No. They have to have 90 degree angles, too. And so, for example, if we do input file 4 is very close to the same one, except the starting and ending point is 0, 1 instead of 0, 0. It's 9 to 90 degree angle. And so this is an other, it is not a rectangle. Okay, that's the only tricky part on this whole thing. I would worry about that part last. But I'm going to give you, I'm going to give you like maybe 2 input files. And there's going to be like 10 or 20. And so I want you all right now to make input files that just look like this, just a bunch of numbers. Input, and then paste what the output should be. And if you haven't done your code yet, then this is a great way of doing TDD. You are coming up with all the test cases. Again, this is something that I've been emphasizing harder this semester than in semesters in the past. A lot of students are, because I give them the input testers, they become sort of reliant upon them, and they can't generate their own tests. They just assume that tests will always be given to them, and in reality, you have to make your own tests for code. So for this one, I'm going to give you like 2 just to make sure that you're, spelling, all this stuff properly, because I everybody hates it when, you get a 0 because you forgot a colon or something, I'll give you a couple just to make sure the spelling and syntax is correct. But all the rest of them you are going to make and you're going to post onto Discord right now, and just just do something like this. Just select the input, and if you go backtick, paste, backtick, that will paste it in an easy to copy and paste format, and then put the answer. So input, output, and I want you all to spend the next 20 minutes working on that. I'm going to go ahead and pause the recording now.
There's boba on the coffee
and then,
table.
What's that? There's boba on the coffee table?
Mm-hmm.
All right, I'm going to go get some boba then. And then it's public. I want you all to share the inputs and outputs with each other and group, work on this collaboratively. Come up, because when you're in an organization, you're not the only person making tests. Lots of people on your team are all going to be making tests. And a lot of times people on your team are going to think of edge cases that you didn't think of, right? Like, what if you have 4 points, but they're all in a straight line? That's not a triangle, right? That's a line segment. So, yeah. We're going to crowdsource your testing. We're going to be doing TDD. You're going to have all of your tests. You're going to make your own files, and then when you want to see, I would just vim a file called like input file or whatever. You can call it whatever you want, but if you want to run your code on the input file, you do it like that. The left arrow, the less than sign, redirects the text of the input file into the program, so it is as if I had typed this from the keyboard here, and then it runs it as if I had typed it from the keyboard, but I didn't type it. It came from a file instead. Okay? And you should get into the habit of making your own test cases. You could use G-test for this, but for this assignment, we're just going to be using input files, just end-to-end testing, because for all intents and purposes, this whole program is just a function call, so it's effectively the same thing. Okay. The input files need to vet code that checks rectangles with right angles and collinear lines. Yeah. Mm-hmm. And what if you have a duplicate point or something, right? Like you have a rectangle and you go 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, and you have a duplicate point somewhere on there. You have to check for that too. There's a lot of weird little edge cases that you have to think about. Always start with like the basic cases: empty file, point, line. You should be able to knock those out real fast, and then basic triangle, basic rectangle, axis aligned, whatever. And then after that, start thinking about the weird edge cases and things like that. Okay. Does file extension matter? No. C++, because you're not reading. No, you can redirect any file into any file. It doesn't care. It's Unix, right? C++ isn't doing. You're not doing any IF streams or anything on like this. You're just reading from CN and writing to CL. But because you do input redirection, when you're reading from CN, it's actually reading from a file. And it's cool. You can just write your program working with the keyboard and keyboard and screen, but then it works with files with just a little bit of input redirection. Yes, girl.
What are they trying to? What are they trying to ask when they're like?
All right, that was fun. Watching the chat. If you're watching this recording at home, the chat was full of interesting and conflicting information, which is exactly what it's like when you work at a company. People are talking about, wait, is this what we mean? No, it's not. Is it? I don't know. And that was actually kind of a fun experience. Do linear need to be accounted for? Yes, they need to be accounted for in this one. Yeah, that's the only tricky part. So if you don't handle it, you lose like a point. It's not a big deal. Okay. Am I streaming? I am not, but I'm also not doing anything right now. Okay. So let's move on. Let's talk about another major thing, and that thing is called Bitwise Operations. So our third main point for today is Bitwise Operations. So what does it mean to do a bitwise operation? It means you're actually working on individual bits. Normally, the smallest number of bits we can work on at a time is with a char, which is usually 8 bits, right? That's usually the fewest number of bits we can work with at a time. When you work with bitwise operations, you work with as few as 1 bit at a time. Okay? And yeah, don't apologize, Micro. It's all good. I posted other when I copied and pasted incorrectly. The example I gave was a rectangle. I pasted other, and then I went to go get a boba, and caused all sorts of confusion. So it's all good.
Why are you ordering bobas or confusion?
Because I left some bad information on chat, and then I walked away. It was from Mintea, Mintea. They're pretty good. All right, I've been to most boba places.
This jasmine tea is pretty strong.
Pretty strong jasmine tea. All right. Okay, so anyway, okay, so normally we work with 8 bits with a char. An int is usually 32 bits, but it could be 16. Yeah, not happy. A long is usually 32 or 64 bits, depending on if you're on Windows or Linux. Or as I've come to call it these days, GNU/Linux or GNU plus Linux. So, yeah, if you use long, you're in for a world of hurt if you port back and forth between Windows and Linux. Because it's standardized with 2 different sizes. I used to get paid money to fix problems porting between different platforms. I got paid a fair bit of money for that because people did things assuming that their code would only ever run on this one machine ever forever. And you know what, time goes on, and people want, if your code's good, they want to run your code on a new machine, right? And then it breaks because you made non-portable decisions. So I actually don't recommend using any of these things. Int, you'll see me use int all the time. You know, if you see me say like for int I equals 0, I is less than 100, I plus plus, that's fine. It's not a big deal. It's 3 letters. It's easy to type. You're not going to overflow with 100. You know, it's fine. But if you're ever getting up into bigger numbers, be aware that ints can be 16 bits sometimes, and that's 65,536 or so. And so, if your numbers are ever going to exceed 65,000, probably shouldn't use an integer, right? Instead, you should specify directly preferred method. Specify how many bits you want, right? So you, instead of a char, use int 8. If you want 32 bits, If you want 64 bits, okay. If you want an unsigned integer, 64 T. Okay. If the number of bits you have matters, then you should just specify them directly like that. Okay. Could you namespace int32 to int? No, I don't think so. But you can do something like this. You can say like using u64 equals unsigned int 64q. That's very common. If you look at, I think the Unreal Engine uses those aliases for everything. So you will see them make a 32-bit integer, like that. And then it's, yeah. So they have these aliases set up somewhere. And then you just use 3 letters, and then the main advantage of int goes away. Int's 3 letters, that's its main advantage. Use int when you want the system to pick the fastest integer type, but that's dangerous because usually the number of bits you need actually matters. And so if the number of bits you need actually matters, use one of these specific fixed size types rather than using enter, char, long, or short. Okay. All right. Oh, sweet. Yeah, they're good too. They're good too. Okay. So, how do we mess with individual bits? Well, here's the thing. You know, the main operations in a data structure are what? ISD, right? What are the 3 most common operations that we do on pretty much every data structure? Maybe not stacks and queues. We don't really search them to spoil what S stands for. But usually for like vectors and linked lists and hash tables and things like that. ISD, insert, search, and delete. Yeah, exactly. So those are the big 3. And so with a bit field, this is our last data structure. It's called int. Okay. So I'm going to make a data structure named inventory, and it is a very advanced, very complicated data structure called int. Okay, or if I want to be a little more proper here, make it a 32-bit int. Okay, just so I don't get surprised if I move to a different system with 16-bit integers in it. Okay, Mancarelli, you got a meme for this? This is the last data structure you guys are going to be learning this semester.
More. Make a meme.
Int. Yeah. So, this is a data structure. Data structure that holds 32 bools. Okay. Now, you might be saying, well, doesn't the bool type exist already? Yeah, there we go. Sweet. And doesn't the bool type take up 1 bit of RAM? Nope. It doesn't. The bool type, here, let's do this. Bool B, let's see out the size of a 32-bit integer, followed by the size of a 64-bit integer, followed by the size of a boolean. Let's try size of. Maybe that'll work, huh? Finish typing. Okay. So you can see here that integers are 4 bytes, unsigned longs are 8 bytes, and bools are 1 byte. And in fact, bools could, I think in C, they were actually held as integers. And so if you're storing a bool, which is just a true or false, it's 1 bit, true or false. It actually would use 4 bytes. It would use 32 bits to hold 1 bit. In C++, at least on our system here, it uses 8 bits to hold 1 bit, which is extremely inefficient. And so The thing is, like, you can make a very complicated data structure called an int, and that is a data structure that holds 32 bools. Okay, and we need to learn how to individually access and search and delete each of the 32 booleans. Okay, and we do so using bitwise operations. And the bitwise operations are single vertical slash, single ampersand, caret, and tilde. Okay? And these correspond to OR and XOR and NOT. We don't really use XOR too much, at least in this class, but it's useful for like cryptography and things like that. All primitives are data structures. Yeah, they're all data structures of booleans, right? Because they're all multiple bits, and so any if we wanted a data structure of 64 bits, we could do so like that. Okay. So bitwise operations work like this. Rather than we all know, like, x ANDed with y or something like that, right? When you do a single ampersand, what happens is that each of the bits within the variable are treated as separate variables, essentially. So if you have 1100 and you OR it with 0101, let me do it vertically so you can kind of see what's going on here. If you OR it with 1010, then what happens is each of these individual bits get ORed together. Okay? So it's not treated as a regular variable. Each of the bits inside of it are treated as separate variables. Okay? So true ORed with true is what? True. If it was XOR, it would be false. Inclusive OR, regular OR. If either side or both sides are true, the answer is true. Second bit. True ORed with false. True or false is true. True. With OR, either side, either one or the other is true, the result is true. And then for the next one, it's true, and then false ORed with false is false. Okay, so that is the bitwise OR operation. For bitwise AND, each of the individual bits are ANDed together. So what is true ANDed with true? Is it true that both true and true is true? It is very true. Yeah. True. And then true ANDed with false. True and false is false. False and false and false is false. Okay. You see how this works? So if you have 32 bits, I'm only drawing 4 of them here because I don't want to be here all day. But if you have 32 bits, all 32 bits get ANDed or ORed, whichever one you pick, with the 32 bits in the other one. Okay? And that's why students get very confused when they do caret, expecting it to be exponentiation, because it's not. Caret means XOR, exclusive OR. It means one or the other, but not both. So for exclusive OR, true XOR true is false. For XOR, it means exclusive OR. One or the other is true, but not both. In this case, both bits above it are true, so the answer is false. True XORed with false is true. False XORed with true is true. False XORed with false is false. Okay, so there's all the possible outcomes for that stuff, and that's why if you do something weird, like cout 2 to the 8th power, yeah. If you cout 2 to the 8th power, that's not 2 to the 8th power, right? That does not mean 2 to the 8th power at all. Instead, actually, let's do this operation right here. So this is the 1's bit, 2's bit, 4's bit, 8's bit. So the first number here is 12. And this number here is 8 plus 2 is 10. So if we say, what is 12 to the 10th power, the answer we're going to get is 6. This is the 2's bit, this is the 4's bit. 2 plus 4 is 6. So 12 to the 10th power is going to be 6. And this is deeply concerning and confusing to CSI 40 students who just want exponentiation to work. They don't know about the POW function yet, so they try the caret, and it compiles and it gives them a number, but 12 to the 10th power, I guarantee you, is not actually 6. But this is not exponentiation. This is exclusive OR. Does it have a word like and or? I don't know. Let's try it. XOR. Yeah, there you go. So that's more confusing to people. So I recommend you use that for job security. Okay. Do you read from the left to the right for bits? Yes. A brief primer on bits. If you have 1011, what number is that? That's the 8-bit, the 4-bit, the 2-bit, and the 1-bit. Okay, so that's 1 plus 2 plus 8, 11. Okay. This would be 2 plus 4, the 1-bit set, the 2-bit set. 2 plus 4 is 6. Sorry. That's 3. 1 plus 2 is 3. That's 9. 8 plus 1 is 9. And the more bits you have, the most significant bits are to the left. All right. I'm only drawing 4 bits at a time because I don't want to write 32 bits. It takes too long. If you open up your calculator on Windows, you can put into programmer view and see the bits there as well. Okay, so how does this work as a data structure? How do we do insert? How do we do search? And how do we do delete? Well, there's a pattern that you follow for these things, and it works like this. So we're going to start off with our inventory being 0, and let's just drop these off the bottom of the screen. And we're going to make some constants, and the constants are all going to be powers of 2. So we're going to have weapon axe is equal to 1, constant. And we can do this with enums as well. Weapon single-barreled shotgun equals 2. The double-barreled shotgun is 4. The nail gun is 8. The rocket launcher is 16. And what we're doing is we're essentially naming each one of the bits within this inventory. This inventory can hold up to 64 items that we either have or we don't have. And if you're wondering, this is actually how Quake did it. It used a 32-bit integer. Actually used a 24-bit integer, but let's not talk about that now. Really, they had their own weird format thing. So weapon rocket launcher, and then maybe we'll have like the super nail gun, something like that. I don't know. Okay, and so yeah, it was a combination of an int and a float format, and so it was weird. Normally floats don't work with bit fields, but they wanted to be able to support large numbers and small numbers. And so they made their own weird format. There was 24 bits of integers, and then the last 8 bits were an exponent. So you could kind of shift them left or right, to make bigger and smaller numbers. It's kind of an interesting format. It worked pretty well. Using this, what's the biggest inventory you can have? 32. You can have at most 32 different items in the game that you could pick up or drop. And in Quake, when we ran out of bits in our inventory space, we made... You ready for this? Inventory 2. And we got 24 more items that we could pick up and drop. So yeah. Mm-hmm. And then, are you ready? Inventory 3. Yeah. True story. So they're named something different, but that was basically the idea. Except I had no data structures. There were no, yeah. So you have 3 different data structures here, and yet you had to remember which which data structure was holding which types of items. So the keys were held in like a key bit field, and like weapons were held in a weapons bit field, and then like your Team Fortress items were held in a Team Fortress items bit field, things like that. So, yeah. True story. Okay, so you set up all your constants. If you want to see what it looks like, like in practice, in actual production code. Visual Studio Code. There we go. And let's scroll down. There we go. Build Flame Edition 1. Build Frost Edition 2. Air Edition 4. Wood Edition 5. Weapon 16. See how everything's a power of 2? All these powers of 2. Powers of 2. Powers of 2. Each one of these things are going to different bit fields. Very commonly used. Powers of 2. Powers of 2. These are all held in different bit fields. You had to know which bit field went into onto the third. So I tell you, onto the third 24-bit wide bit field for holding purchases. You know, inventory 3. Here we go. Let's go. So, yeah. But what's nice about it is that rather than using like 32 bools, you have an int, right? So it's 8 times more compact than having a different variable for each one of those things. And that really matters, especially when you're doing things like networking, because networking is perennially in need of lower latency and higher bandwidth. And it irks me to this day how wasteful of bandwidth most modern video games are. Like the network code in most modern video games is absolutely atrocious compared with the quality of the network code back in the 90s. Because back in the 90s, people had to play on modems, and modems were really slow. 250 millisecond ping times were like considered pretty good for a modem. Usually you're playing up in the 300s and 400 milliseconds. So that means the time it takes after you click, it's like a third of a second, you know, in latency. And so the game developers did everything they could to minimize and squeeze down as few bits going out in both directions as possible. A Quake connection ran at 5K, so 5 kilobits per second. And you could have 32 people, which is more people than like Overwatch supports, right? The people move faster, and there's more stuff going on the screen. The reason why people move so slow in video games these days is because their network code sucks, you know. And in Quake, when you play Quake, like you're running around at high speeds, and it just handled it, and it was quite good. And if you were playing on an Ethernet connection, you had a 10 millisecond ping time, and the thing was just like chef's kiss, beautiful, you know. Like it was amazing. You could have 32 people running around at high speed, shooting each other without any latency. And nowadays, it's like Overwatch is like, no, we can't have more than couple people on the screen or everything breaks. It's terrible. So is that the same as Mantissa for floats? No, it's their own weird format. IEEE 754 format, which is what floats and doubles use, isn't like this at all. Like they made their own kind of special thing for it. So
Daddy,
modern game devs have gotten lazier and lazier.
Daddy, when they were asking how did the Chinese Exclusion Act affect the Chinese immigrants in California, do you mean what they like when they caused the effect, what happened to them, or do they mean how they actually created the effect?
I'll answer that once I'm done with class, girl. Okay.
No, it's very quick.
I'm gonna need to look at it, girl. Okay. Yeah, no, modern game devs are lazy, especially when it comes to network code. Like, for the amount of money that like Pokemon Go made, you think they could hire somebody who just specialized in network code and just fix their terrible networking. Like, you would play Pokemon Go with like 1 or 2 bars, it'd be unplayable. You click on a Pokestop, and you couldn't spin the Pokestop until it loaded an entire image into the disk. It's like, I don't need to see the thing, I just need to spin the damn thing. But it's like, no. We went to all this effort of having these pictures in here. You need to see it. And you're sitting there like, oh, Lord. And then, like, there would be no Pokemon on the ground, and then 30 seconds later, all the Pokemon would spawn. Like, it was just this buggy, laggy, terrible mess. And if you think about it, Pokemon Go really doesn't have that much of a bandwidth requirement, right? You need to be able to just send the X and the Y location of a Pokemon near you and the Pokemon index number, which, how many Pokemon are there? 900. Send it as a short, 16 bits to say what type of Pokemon it is, an X and a Y location. That's it. At most there's maybe 20 Pokemon on the screen at once. That should not require 30 seconds of latency and lag, and literally the largest IP in the world, and they couldn't hire just a person who just specializes in networking protocols for games, right? Just rewrite it, make it snappy, make it instantaneous. I always thought the Pokemon should walk around a little bit.
Maybe it's a pay offer for one of your students.
Kearney, the history teacher. I worked in history for a while. Yeah, it's like, they made $1 billion. You can't hire a guy for, pay him or her, pay her $300,000 a year. Get the top person in the world to sit there and rewrite your network stack. Like, come on, it's just ridiculous.
You make $1 billion a year. You can afford someone, okay?
You can play Quake on a Raspberry Pi, but Halo Infinite takes 100% of your 3060. Yeah,
and even the trashiest, even the trashiest computer science person could do that.
Mm-hmm. No, it takes a fair bit of intelligence to write a good network stack. Okay, so let's do this.
Any standard computer science person.
Anyone who's gotten I don't know. You kind of have to study networking.
Fine. Just hire someone, please.
Yeah, I think so. I think they should hire somebody.
Please, you're making $1 billion. That's enough to hire someone. Just do it.
I agree. I'm right there with you, girl. I think they should have, because it's just laziness.
Like I said, maybe it's a pay offer for one of your students.
Basically, our summer right now with refactoring, but professionally, yeah. Mm-hmm. It didn't stop people from playing the game. I don't know how many. Like, if you had 1 or 2 bars, you couldn't play it. So how many people did they lose? It's hard to say. Yeah. Bungie hire me, add more FOMO into Destiny 2. That's funny. Okay, so here is how you do an insert operation. So inventory right now is 0, and so 0. Let's just sketch this out. 0 is all zeros. And weapon double-barreled shotgun is 4, 0, 1, 0. And if we bitwise OR these things together, then we get 0, 1, 0, 0. You see that? So the bit corresponding to the number 4 means we have the double-barreled shotgun. Okay? So by doing this command, our inventory now is 0, 1, 0, 0, meaning the 4-bit is set, we have the double-barreled shotgun. All right, let's add an axe to it. And also my axe. What happened there? Okay, so if we do this again, let's just override this here, then that is the result. You see that? You go through each pair of bits, you OR them together, and you see that the 4-bit is set and the 1-bit is set, meaning that we have the 4-bit is the double-barreled shotgun, the axe is 1. By the way, this is also anytime you work with the Linux kernel, anytime you work in C-World, when you pass in a bunch of options, if you've got 32 different options, it could be true or false, it typically is passed in as one integer as a bit field. And you pass in a set of bits that are set or not set, and that indicates do this option yes, do this option no. I want it in read-only mode. I want it to truncate the file before I open it. You pass in all the options you want as just a single integer. Done. Okay. Do you guys understand this? How this works? This is the pattern. The pattern to insert something is you take your bit field, you bitwise OR it with the thing that you want to add. If you already have it, it does nothing. You don't get duplicates. Make sense? That's insert. Okay. Now we want to do search. Okay. Bitwise AND. So if we're going to do a bitwise AND, our inventory is 0101 currently, and we bitwise AND it with 01. You go through each pair of bits. False ANDed with false is false, true ANDed with false is false, false ANDed with false is false, true ANDed with true is true. If the result is not 0, that means we have the X. So this is asking, is the bit corresponding to the X set? If it is, we have the X. If we don't, we don't have an X. Okay. You guys understand? Easy. And if you want to check for multiple things, you can actually do that in a single cycle. It's actually more efficient. If I have the axe or the double-barreled shotgun or the rocket launcher, and this will check to see if you have either of those 3 items in one cycle. Much faster than doing 3 if statements. Okay. Kind of cool. All right. So that's search. You guys understand search? Okay. And then delete. Inventory is equal to inventory. Bitwise ANDed with the not of weapon DBS. Delete the double-barreled shoddy. Okay, that's how you do it. So an AND with the bitwise not. And so bitwise not, this is all order 1 time, yes, absolutely. The bitwise not of 1011 is equal to 0100. Bitwise not is, whoops, all the bits. Okay, and so when you not something, it just turns all the bits upside down. And so if this was our inventory, what do we have? 1010. If you AND it with the not, so we had that as our inventory, I think, right? DBS and axe. Okay, that's our inventory. And then we AND it with the not of DBS. DBS is 4. 4 is that, right? 1 bit, 2 bit, 4 bit, 8 bit. So that is the double-barreled shotgun. So by bitwise inverting it, this turns into 1011. And so if you take your inventory and you AND it like that, then you get false, 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 true. And so you end up with just the axe. Okay. So it turns off, when you AND something with true, it does nothing. But if you AND something with false, it turns it off. And so it's turning off just the bit corresponding to the double-barreled shotgun. And you save the result. And there you go. So that is how you treat a integer as if it was a data structure. You can insert into it, you can search it, you can delete it. Okay. That is our class for today. And if you have any questions about the assignment, I expect you to post questions in the Help Center, and I will give you the answers as to what a test case should produce as results. It will be graded on Friday, and then on Friday, I will scramble up all of the assignments. And if you have an especially bad one, send it to me, and I might just give everybody that one. I don't know. Okay. Yeah, we do have a Bitwise assignment as well. Okay. All right, that's it for today, guys. Hope you had fun, and I will see you on Friday.